It's my pleasure to be here at Focus Conference, together with OEM customers, partners, and many expected industry peers. I need to thank Focus. This is my first time to be here to have this chance. My name is Nina Ding from Pigment and Dispersion team at BASF Coatings. And today I'd like to explore with you about how we move beyond conventional pigment and how photonic crystal technology open new possibility for automotive OEM colors innovation. In coating system, color is no longer just styling. It has already been a strategic differentiation. And today, OEM expect color to be reinforce their brand identity, communicate innovation and sustainability, and increasingly a differentiation in a crowded market. This raises us a critical question. Can today's pigment still fully support tomorrow's color strategy? We are moving from what color is it to how we, the color behavior in the real world. Let's start from the reality check. You know, at BASF, we published a global automotive color report every year. From this chart, you can see if we look across EMEA, Asia Pacific, and Americas, the color in 2025, we still found a strong dominance of white, black, gray, and silver. While the share of chromatic color varies by regions. That doesn't mean that OEM want less innovation. In fact, it tells us something much more important. They need two requirements at this time. One is safety, robustness, and long-term reliability. The other one is the need for differentiation and emotional appeals. The balance of this changed the nature of innovation. So instead of asking what kind of new color we should introduce, the question increasingly becomes, what can familiar color in behavior? So today my topic is about photonic crystal. So, you know, currently the design trend work becomes truly meaningful as the early signal of changing perception. This is our BASF trend work. We mainly focus on three dimensions. First one is progress and innovation. Second is society, and sorry, I cannot see it very clear, interaction. And the third, identity and individuality. This framework helps us filter what is the global relevance, and what's the and today my topic will focus on progress and innovation. We just introduced the research trend, and now we move to color ideation. From research, we introduce how practice in BASF. Here is not a linear process for linear process. It's connecting color innovation trend color definition, color design, and new pigment exploration. And the new pigment exploration is not the end of this process. It's an interact loop connecting of this part. And from our process, we start from trend signals, digital overlays, and virtual tools. This part defines a shift in perception. From there, we move into its operation. This perception signals becomes emotion directions. For example, depth, excitement, and refinement. At this stage, we already began to think about how the perception should feel, and how we feel in color. And then the design turned it into intent. Let me take nocturnia as one of my example. The design target for this color is not just deep blue. It's blue that change character and diffuse light, calm and refined. And the direct light is active with a vivid sparkle. And with angle, it shaping into dramatic depth. If color were a person, nocturnia would the one who looks quiet until you put a spotlight on it. And finally, the pigment innovation enabled this behavior. Okay. I would like to explain why I have used nocturnia as my example color. Based on the customer feedback for 2025 to 2026 trend color collection, nocturnia ranks number one. So actually, this confirmed from OEM perspective. Relevance is no longer defined by color tone alone. It's what's make difference behind is color perception. In other words, customers are not voting for a blue color. They are voting for a perception experience. So actually, I took this panel with me today. So maybe later you are very welcome to take a close. You should check the color and diffuse light and the color and direct reflect light. Yeah. So at this point, you may wonder, what kind of pigment technology can enable this kind of new perception space? This will bring us to the today's focus, photonic crystal. Before I introduce the detail, so let me firstly show a short video. Okay. Actually, photonic crystal pigment combine four benefit cluster. First one is unique color effect. It interacts with light in fundamentally different way It controls light through structure, delivering high purity, high chroma, vivid optical depth, and also strong angle-dependent effect. The second one is tailor-made controllability. Through this precise wavelength engineering, so we can control the color shift profile. This can increase our freedom for color design. And third, sustainability. So this photonic crystal is a polymer-based pigment. There is no heavy metal. It has very good color stability and durability. The fourth is radar-lidar performance. They contain no conductive inorganic material, which avoids common inference mechanisms and make them inherently compatible with the radar-lidar system when designed at coating system level. So far, we have talked about why color perception matters, and now let's look at how we can enable differentiation in practice through photonic crystal pigment. Attractive color is primarily defined by the base coat layer, with a clear coat layer playing a small role in certain cases. When we look at pigment landscape for automotive base coat, it's highly mature. We are working with two main categories, colorants and effect pigments. For colorants, we are very familiar with organic pigment, inorganic pigment. And for effect pigment, on the inorganic side, the aluminum in different type and morphologies are already well established. For pearl, based on different inorganic substrate are also widely used, and also some other special structure pigment. And Lingyue just mentioned her structural pigment. I think it still belongs this part. However, when we come to organic effect pigment, this area has far explored so far. This where the photonic crystal pigment came into the picture. Let me compare this different pigment type with mechanism perspective. So for the absorption pigment, create color by removing part of the spectrum. For the reflection metals, return light directly, often strongly directionally. For the interference pigment, rely on layer structure and orientation. But photonic crystal behave very differently. They are polymer-based pigment and have a nanosphere stack structure, delivering bright diffraction. So you see, different mechanisms lead to different control over purity, depth, angles, behavior, and ultimately it's design freedom. Same word, color, but you say totally different job done by physics. Actually, photonic crystal technology is not new. The early concept date back as far as the late 19th century, inspired by natural photonic structures. And the theoretical fundamental was established in 1987 when Eli Yablonowicz and Sanjeev Joy introduced the concept of photonic band gap. That was followed by experimental verification. first in the microwave regime in 1991, and then at optical wavelengths in 1996. And between the late 1990s and around 2010, photonic crystal moved into device application, with the first emergence of organic photonic crystal. Over the last decade, we have seen repeat program in material and processing. So today's story is not about a new discovery, but a technology that now is mature enough to be discussed in real coating system. Here I will explain one of the most important points for OEM feasibility with photonic crystal pigment. You know, the traditional inorganic effect pigments are typically also photic. Their appearance strongly depends on the flake orientation. That means very small variation in alignment already lead to a visible difference in color and effect. But the photonic crystal behave totally different. They can more isotropic, but of course, this can enable consistent appearance and more predictable outcome. But you know, if this photonic crystal pigment applied in OEM coatings, we still need some innovation. Not only the pigment itself. Let's look at the flake particle size distribution and also the optimal principle. The wavelength of red is larger than the green, and the green wavelength is larger than blue. So we still need some innovation in film structure design and application process adaptation. So photonic crystal technology is not a single material solution. It is a system level innovation. Based on this Bragg diffraction mechanism of photonic crystal pigment, we gain a powerful design level by adjusting the diameter of the nanosphere, and we see shift reflected wavelengths across the visible spectrum from the longer wavelengths on one side to the shorter wavelengths on the other side. That means we are not limited to blue effect. We can explore a much broad range of structure color behavior. For example, from green to blue shift, and also from red to green transition, and more other complex effect. Of course, not every effects will be end up in serious production, but that is not the key point. The real value is it changes how designer can think the color, from choosing a tone to shaping a perception experience through structures. Okay. And now, before we get too excited, we test. So this section shows the technical performance in our automotive coatings. Yeah, I will show the initial customer evaluation benchmarking photonic crystal technology versus conventional pigments. The strongest signal is very clear. Photonic crystal pigments scores very high in visual impact and color attractiveness and in color uniqueness. System compatibility and fundamental film performance are also rated strongly, while the processable film bed require continued system work. And also I put some performance panel here. This is initial adhesion and high pressure water jet. And the humidity post stone chip with different method. Also the color panel and performance panel before durability and after durability. You can see all of these results are okay. So the message is balanced. This is not a magic pigment beats everything. This is a technology that with a very clear differentiation strengths and a very clear integration paths. Let me finish my today's presentation with a short summary. Photonic crystal offer new next generation structure color platform, delivering exceptional purity, tunability, and visual impact. They create clear color definition advantage, enable a new language for future brand identity. And at this same time, this is the technology is not just unfeasible part. It's already feasible. It's the visible performance and the system compatibility has been validated with a very high level of technology readiness. And to enable implementation in existing OEM plants, adaptation is required. Cross-pigment design, structure, layer structure, and application adoption process. And that's why industrialization will be collaboration-driven, accelerating scale-up through close OEM co-development. So thank you very much. Let's shape the future of automotive color together. I'm looking forward for your question and any comments. Yeah, thank you.
All right,
I
any
think
questions
you
in the room?
already checked the color, everyone. What's your feeling? Very nice, huh?
Yeah, thank you, Nina. This is Toby from BASF as well. And I just want to ask one question. What about the price or cost range of this photonic photo pigment compared with the traditional or typical pigments?
Yeah. Actually, from a technical perspective, I cannot disclose the price because we want to screen strategic partner, but compare with the traditional structural pigment, which Lingyue just mentioned for this Lexus, you see the price of a structural pigment is so expensive. We just talked about several years ago when I worked in refinish color lab. I must use that pigment to develop this Lexus color, and the quotation is 100 per gram, 100 RMB per gram. I think it's expensive, much more expensive than gold. Today, I would like to say it's a value for money. Yeah.
Thank you for the presentation. This is Sharon from Axalta. I have a quick question. So do you guys have a little bit weathering
Yeah,
data?
I just mentioned we already finished the durability test.
Oh, more like xenon exposure type of thing. I don't know if you have some data or results.
This
to
is
share.
a new technology in automotive coatings. So we checked some pre-performance, and we also finished the warm test, and we found the result is okay. Everything is okay. So we will start our global qualification. I'm not sure you know, for each new pigment introduction to BASF, we will do comprehensive tests for this pigment with a different basic coat technology combined with a different clear coat, weaker one, stronger one, to check the usage limitation in our system. And then we will give the usage guideline to the end user, to color lab and customization lab. So next step, we will do this comprehensive test for it. But from the pre-qualification, everything is okay.
Okay, thank you.
Yeah,
I have another question. So you mentioned about it's not only the introduction of the new, pigment type, but also the integration of the whole system. Can you elaborate a little bit more on that? And also how the, when you apply the film thickness and all these properties would impact on the final color? Or is there any sort of, things we need to pay attention?
Yeah, I think you just asked a very good question because when you check the color, you can see some depth. It's totally different from conventional pigment. For conventional pigment, you just see some sparkle or the color part, but this one, under the diffuse, under the direct light, you can see the depth. To get this depth, we need the higher flake thickness. If the thickness is higher, the effect will be better. If we reduce the thickness, the effect will be reduced. Of course, if we want to get a better effect, we need to make a thicker flake. And if we put this thicker flake in our system, we need to change our current process to resolve this appearance effect. That's what I mentioned. We need application adaptation. And this one, did you find any defect on the surface or the appearance? No, just because we already increased the thickness of a clear coat. So you can get a very nice appearance, even you use a very thick flake inside. So that is a balance. One is you want to get a better effect. The other one, you need to resolve this kind of defect appearance issue. Yeah.
Right, and you mentioned about this is like the nanosphere type of structure. And for the crystal, what kind of particle size we're looking at here? This pigment comes from our supplier. Actually, from my side, I cannot disclose this information from my side.
Oh,
yeah. Okay.
Actually, we know what is it and what's the media. Because they need to disperse this kind of nanosphere into some media to get a film. Otherwise, there is no good adhesion performance in our coating system. So you see the pigment looks like the traditional mica. It's a flake, but actually a lot of nanosphere inside.
Okay, yeah, thank you.
That's polymer based. It's organic. Yeah.
Right. Yeah, thank you.
And I also want to mention, from this product, we can see the nanosphere is the diameter is same for different nanosphere. But our supplier also can tailor-made with a different size of nanosphere. That will be generate another effect, totally different from today's effect. Yeah.
One more question from the Huva app, mostly addresses what color space do the photonic crystals cover? Can you get any color with it, or are you limited on sort of the hues that you can get?
A lot of more possibility. I mentioned from the optical reflection mechanism, we can always get color from the right direction to the left direction with color shift. And for this one, why we select this one? Just because the blue one has very high possibility for mass production. So for the color shift strong effect, I think we need to think about how to control batch to batch consistency and how to control the supplier's quality. So that's a problem for the high color shift effect. But for this blue one, which we select in the beginning, has very high possibility for mass production. Yeah.
All right, let's thank our speaker again. We will reconvene at 3:55.